Hello everyone, welcome back to my channel Live Studio. This video marks the conclusion of part 1 of our short series on decoupling workflows using SQS. And in the upcoming videos, we will explore similar concepts using SNS and API Gateway. That being said, in the previous video, we discussed various settings and important configurations of SQS. And today, we are going to dive into dead letter queues and complete it with a demo in our AWS account. So let's kick things off by discussing dead letter queues in Amazon SQS. Understanding dead letter queues is essential for both your own knowledge and real world application designs. Simply put, a dead letter queue is a target queue for the messages that fail to process successfully from your application's primary message queue. This means it acts as a failover queue where you can store messages for inspection and you can replay it later. Now, here are some of the great features of dead letter queue. Starting with a very neat feature with DLQ is that it can actually work with both SQS and Amazon SNS. So that gives you a broader visibility, a broader reachability to other applications. Another great feature, DLQ is going to be very useful for debugging your applications. Thirdly, they allow you the ability to actually isolate the unconsumed message and then troubleshoot them on your own time. Another neat feature that's also critical for the real world applications is that you can actually redrive your message. This means that you can enable redrive capability and it allows you to move that particular message back to the original source queue. Now, essentially, dead letter queues are just another SQS queues. There is nothing inherently special about them. It's just their application in your infrastructure design that defines their purpose. Lastly, I want to highlight that you can use a dead letter queue with FIFO queues as well. But the only thing that you have to keep in mind is that if you do so, then the dead letter queue must also be a FIFO queue. Now, I have a really short section or short video on FIFO queues. So I'll be covering this in that particular section. Now, let's visualize how a dead letter queue operates within a messaging based application system. I'm sure you must be very familiar with this graphic by now. So once again, we have a happy user at the top with an EC2 instance serving as a front end of our application and another EC2 instance acting as the backend. The front end sends message to SQS while the backend reads or pulls those messages from the queue. Now, if our happy user submits an order online, a message is populated in a primary queue. However, if the message processing fails on the backend, then the original message will be wrapped in another message and forwarded to the designated data queue. This allows us to identify and investigate the specific message causing the error. If we determine that the error is intermittent and not a significant issue, we can easily replay that message in the original queue using the redrive feature. Now, you must have got a brief idea of how this works. Let's take a moment to set up an SQS queue and configure it to send any failed message to the separate dead letter queue. Now, in order to see this in real time, I'm going to create a simple setup for you to make you understand how SQS, a queue, and DLQ works. So, for that, first, this is our AWS console, and I'm going to head towards simple queue service. Uh, go here, create a queue. We'll go with standard queue, and let's just give it a meaningful name. Um let's say order queue. Okay, we are going to leave the settings as it is. Now, if you have any doubt, you can refer to our previous video where I've explained everything about the configurations. So we are not going to change any configurations for this demo purpose. We'll come down encryption. Again, no change. Server-side encryption is enabled by default, and the key type is by default Amazon SQS key. And I've also mentioned that by default, the messages are encrypted in flight, and it is the messages are non-encrypted when they are at rest. And if you want to perform end-to-end encryption, then you can select AWS key management key, like KMS service, and provide your own default encryption key. But for the sake of this demo, we are going to stick with Amazon SQS basic default key. Access policy, we are going to leave it as it is, and access policy basically defines that who is able to access this queue, who can send message, read message. So if you need a cross account permission to send or receive message, then basically you need to edit this policy. um, Retrieve allow policy, this is not a setting which should be active in primary queue. Instead, this is what dead letter queue has to be enabled in dead letter queue. Then comes a dead letter queue. We are going to enable this because we want to route our all the failed messages to dead letter queue. But for now, we'll keep it as it is because we do not have any dead letter queue. So that's it. Let's go ahead and create a queue. Now this creates a queue in our account by the name of order queue. Now let's go ahead and create a dead letter queue as well. It's the same process as I've already mentioned. Dead letter queue is nothing but a standard queue, but it just have one basic quality which is known as read drive messages, and I'll show you how this works. Again, let's just give it a name, orders DLQ. Again, no change in the setting, encryption, access policy. Now, this is a main setting which makes this as a DLQ. Now, redrive allow policy ensures that if any of the failed messages lands in the DLQ, then you should have the permission, or you should have the ability to replay that message and send it back to the primary queue. And that property is known as retrieve allow policy. We are going to enable this policy, and on enabling we get three options: allow all, by queue, and deny all. So allow all setting ensures that any queue in the account, in this particular account, will be able to use this particular queue as a DLQ. By queue means not all the queues in this account will be able to use this. Instead, we can provide the ARN of the specific queue, which can use this particular queue as DLQ. And deny all. I don't even know why this option is here, but deny all basically says that no one in this account can use this queue as DLQ. But basically, why do we want that? So we are going to go with allow all because we just have one queue. So it doesn't make sense to like limit it by the queue option. Uh, After this, leave it as it is. We are going to create this queue. Now this creates our dead letter queue as well. Now, as we have DLQ in place, now we can go back to order queue. We are going to edit this setting, go back to the bottom of this queue, and enable this option and select. Now you'll be able to see this orders DLQ here, and maximum receives, I'm going to keep it as 2. Now what does this mean? It means that if number of times a message receives to be sent to the DLQ, for example, if the failed message attempt is more than 2 times, then automatically that message is sent to the DLQ from the primary queue. Let's go ahead and save this one. Now we have successfully created the DLQ and SQ primary queue. Now, first part of the video, basic setup is done. Now we'll see that how we can trigger or send message to this queue from a Lambda function. For that, we need to access our Lambda function. Go to Lambda, create a function, give it a name like order function. Let's give it a name. Let's select runtime as the latest one. Now for this you need an IAM role as well. So I've already given the permission for my particular role. So if I want to quickly show you that what all permissions I've given to this role. So I've given it S3 full access. You don't need S3 full access. So this was an earlier created IAM role. That's why you see this S3 full access here. But for this particular demo, we just need SQS full access permission. You do not even need full access. You can go granular if you have correct knowledge of IAM. And please, if you need like in-depth video for IAM, then comment IAM in the comment section. Just leave a comment there, and I'll make sure that next video I'll be creating using IAM and how can we use roles and policies to the granular level to control the permission. That being said, let's go back here and select the role for this particular demo. This should create our function. Now, one thing. Now, in order to send message to queue, we are going to use Boto3 client. So let's just go ahead and import Boto3. Let's create a client. Boto3 dot client, and we are pass SQS. If you are familiar with Boto3 APIs, well and good. If not, you can just go ahead and simply type Boto3 SQS and you'll be getting the first link. It's always the first one if you type Boto3 and the service name. And to the very bottom, we see this API called send message. Now, all we are interested in the first two parameters, queue URL and message body. Let's go back to our function. And what we're going to do is we are going to type in response, and as a part of response, client dot send message, and here we are going to provide the two parameters. One is the queue URL and second is the message body. Now, as a part of queue URL, go back to your SQS queue and select this URL here. Uh, you need to paste this URL here and provide any message. Hi, this is my first message. That's it. uh, Now, on deploying this and testing this, this lambda function should be able to send a message to the SQS queue, and we'll see that in a moment. So let's go ahead and click on test. Bingo. So message has been sent. Now, in order to see whether the queue has received the message or not, go to the queue section and you'll see this button saying send and receive messages. If you click on this message or button, you'll see that receive messages, you'll see one count under messages available. Now, if you want to see the content of the message or the information about the message, you have to click on this poll for messages button, and this will actually give you the list of messages available currently. If you click on this, you'll see the body of the message. Hi, this is my first message. And you can also see the details like what was the size of the message, the sender account ID. Obviously this is encrypted, but never mind. Yeah, we do not want these details apart from when it was received, and basically the size, or if it's failed, then reason of failing. uh, cool. So we have seen how the queue works. We can send the message from the queue, and we can see we can send the message to the queue and see whether it has been received by the queue or not. And you can also add endpoints to the queue to check whether the endpoint is triggered on receiving the message or not. Um Now we have seen how the queue receives a message. Now let's see the functionality of dead letter queue, because it's a crucial concept, right? Now for that, I'm going to delete this message because I don't want any confusion. Okay, order queue. There should not be any messages available for messages. Yep, there isn't. Let's go back to the order queue. Now, in order to implement this functionality, we just have to make small change. Now, what's that factor that triggers DLQ? That factor is if the consumer is unable to consume the message, or anything goes wrong or fails. In that case, the message is then, after a certain number of retries, which we have kept as two. I showed you the setting. If you go here, go down, we have set the maximum receives as two. So if the maximum receives is more than two for the same message, then it's moved to the DLQ for the further processing. Now, in order to do that, first we need to attach a lambda trigger, because we need to fail it, right? Consumer. So, when consumer fails to receive a message, then that message is sent to DLQ. For that, what we're going to do is we are going to configure a lambda trigger. Configure a lambda trigger. We'll choose a function, which is our order function, and then we hit on save button. Yeah. So our trigger is created. Now let's head back to the lambda function and make that change. Now, in order for this lambda function to fail, first we are going to remove this for sure. We do not want any of this thing, and instead, I'm going to raise exception, and as an exception, I'll just write a message processing failed, sending to DLQ. Okay. Now this does not return anything. We'll deploy the function. Now this function is deployed. Now let's just check the functionality if this actually works. We'll go back to the queue. We'll open DLQ here and this queue here. Um, Currently, there is no messages available, and in DLQ as well, there are no messages available in DLQ as well. Right? The maximum messages available is 0. Now, what we'll do is we'll try to send a message from here. It can be any simple message. Uh, let's say it should be. I'll just add a JSON object with first studio, and that's it. So if I send this message now, technically the lambda function, if we say this view in CloudWatch logs, it should throw us an error or an exception rather. See, it has thrown an exception. Processing failed, sending to DLQ. Now let's see if our dead letter queue has actually received anything or not. Now this is our dead letter queue. If we poll for the messages, there we go. Yeah, it took a bit of time, but now there we can see a message here, and the message is name IFI Studio. Now, this is the same message that we just sent from this terminal, and it failed to process after a certain retries, and after that, it was landed in our DLQ. See, received count is 3, so which means that it retry sending it, processing this message twice, and even after failing 2 times, it was then sent to the DLQ. And that's all for this short demo. I hope you understand the concept of queues and DLQs, and please use this in your architecture because it provides some neat architectural decisions, decoupling your whole application design. And it's really helpful when we are dealing with like in-flight messages, trigger-based processing, and it's really useful in if you are building a scalable architecture. That's all for the video. I'll see you in the next one. Peace out. And please do share, subscribe, and like this video if you like the content, and do share your views in the comment section. Thank you.